So we're talking about functions and how you can compare functions between words and graphs, charts and graphs. There's different ways that you can compare the rates of change of functions. So here a zebra is a main predator. A zebra's main predator is lions. Lions can run at a speed of 53 feet per second. And the graph at the right shows the speed of a zebra. So we have the lion speed right here, and then the graph gives us the speed of a zebra. The rate of change for the lion, they give you as 53 feet per second. We have to look at the rate of change for the zebra, and they're very nice to us because they tell us that for 1 second, a zebra goes 59 feet per second. Okay? So the rate of change here, they actually do the math, but if you need to pay attention on charts, if they're already giving it to you 59 for 1 second, you don't have to do the slope. This is the slope, if you remember. Change of y over change of x, change of y over change of x. That's what they're doing here. Okay? So obviously the zebra is faster than the lion. So on this particular example, a car has a mileage of 22 miles per gallon, and then you have to compare it to the SUV, which is on this graph. Well, once again, they've already given you 19 miles per gallon, so you don't have to do the slope, but you can. Let's do 38, the rate of change, 38 minus 19, that's your y's, over 2 minus 1, which is 19 over 1, which is 19. And that's what they gave you. So they want you to compare the gas mileage. Well, the car gas mileage of 22 is greater than 19 for the SUV. That means that the car has better gas mileage. That's what they mean by compare. Okay? So, let me write this right. When they ask you to compare, those are the kinds of answers. That's how you should get the answer. Here we have a function of m is equal to 140h. So the miles that a speed train high-speed train goes in the past, an older one, was 140 miles per hour. Okay? Then they give, this is in the words, 140 miles per hour represents the distance traveled on the first high-speed train. Okay? Now the chart gives you the high-speed train operating today. That's the chart one. So we have to figure out what the rate of change is in the chart. And if you look here, it's going up by 1, and here it's going up by 217. So for the first Japanese train, it went 140 miles per hour, and I'll signify that with a 1. And the second train, the one that travels today, is 217 miles per hour. Okay? So first they say compare the y-intercepts. There is no y-intercept. It starts out at 0 miles per hour, right? So it says here at 0 hours no distance has been traveled, so the y-intercepts are 0. Sometimes when you're doing your homework, you're going to see that not all of them have 0 y-intercepts. But when it is a 0 y-intercept, What kind of equation is that? What kind of equation has 0 for a y-intercept? It starts at the origin. It is a y equals mx plus b equation, but there is no b, so it's just a y equals mx. What are those called? A direct variation. The direct variation when it's starting at the origin, and there is no b. Okay? So, when we go down here, they ask to find if you ride for 5 hours, how far will the train go? Well, for the old train, the first train ever, it went 700 miles. This train going 217 miles per hour, if you put that into the equation, 5 hours, you're going to get 1,085. So if you're going to compare it, then the train today goes 1,085, and the first train went 700 miles per hour. And it's good to do the subtraction and come up with, what is it, 385 difference, how much faster the train today goes, 385 miles per hour faster than the first high-speed train. Here we have Angela and Benjamin with a monthly phone bill. Angela is paying 15 cents a minute, and to sign up she has to pay $49. Okay? Then we see the graph representing Benjamin. Benjamin starts at $60 an hour, so y equals 60 as his b, where he begins. And then we have to look at the slope, the rate of change, right? So if we figure that out with these 2 points, we do the y's over the x's, the change, and we get 12 over, 8 over 80, which is 10 cents a minute. Okay? So this guy is 10 cents per minute. So with Angela, if I were to graph her, she would be at 49 right about here. And we could look at 200 minutes. We put a 200 where the x is. That's $30 plus 49 would give us 79, right about there. Kind of the same place. Like that. Okay? So we have to find out maybe where, well, first of all, it says compare the y-intercepts and the rates of change. So Angela's y-intercept is 49, Benjamin's is 60, and Angela's rate per minute is 15 cents, and Benjamin's is 10. All right, so we have the rate of change is 10 cents per minute for Ben, and Angela is paying more per minute. It says what will be that Angela paying more per minute is the comparison of the y-intercepts. Of the rates of change. Okay? And of course, Angela's y-intercept is 49 and Ben's is 60. Now when it asks what is the monthly cost for Angela and Benjamin for 200 minutes, we have Angela at 79, which we did a minute ago. And if we use the graph for Benjamin, he'll pay 80. Or you can put 200 minutes here, which would be y equals 20 plus 60. So Benjamin will be paying 80 for 200 minutes. when we see this graph, there is a point right here. This is the 79, this is the 80. But at that point right there is where they're spending the same amount. And then you're going to see that Angela is going to be paying more. So if we go back to what we learned in the past, if we have y equals 0.15x plus 49 and y equals 0.10x plus 60, is there a way for us to, instead of the graph, because that's kind of hard to read, is there a way for us to figure out what point it is that they are equal? Megan. So you can make the equations equal to each other, right? Do you remember that? If we set these equal to each other, that's when they're spending the exact same amount of money at that point where the intersection of the lines are. Past that point is when Angela's spending more because her line is going up faster. So we could do 0.15x plus 49 equals 0.10x plus 60. Oops. So we get 0.05x plus 49 equals 60. Point 5x equals 11, and if you do the math, you're going to get x equal to, let me see here, so we've got 11 divided by 5 over 100, so 1100 divided by 5 is 220. So at 220 minutes, they are spending the same amount of money. All right, so on number 3 it says the cost to rent a raft from 2 different companies. Which company would you use if you rent the raft for 9 hours? Okay, so Water's Edge, it's $6 an hour, right? So this one is cost is $6 per hour, right? This one, it's 15 to 17.25. That's $2.25, and then $2.25. So it's going up $2.25, but it starts at 15. You have to be careful about that. It didn't start at $2.25 here. It started at 15, right? So the difference between 0 and 1, if I had a 0 here, it would be 15. And then from 1 on, it goes to 25, right? Not 15. 0 and 1 is, well, it is 15, but it's actually 13.75 plus 2.25, right? So what is this? If it's going up 2.25, what's that 13.75? 12.75. Sorry. What is the 12.75? Anybody? Because it's going up 2.25 all the way down. But where'd that 12.75 come from?
Oh, I would guess 12.75 came from like was their initial price for the.
Good job. So it's like a deposit, right? They paid a deposit. With Ryan's, it is the cost is equal to $2.25 an hour, but you have to pay $12.75 initial cost. So $2.25 an hour is less than $6 an hour, but you're going to have to figure out when is it better to put down $12.75. So when you do the which company would you use for 9 hours, now you have your 2 equations, you can figure out which one is going to be cheaper. Okay, so for 6 hours, you've got, for the cost of Water's Edge, it's 6 times 9 hours, which is $54, right? For the cost of Ryan's Rafts, it's $225 times 9 plus $12.75. So that's going to be $20.25 plus $12.75, which is going to equal to $33. So obviously, Ryan's Rafts is cheaper than the Water's Edge.